Welcome to the massive open online course on Aspen Plus. In today's lecture, we are going to discuss about batch separation process. Batch separation process will be available in the batch models. Here you will find the batch separation process. It is written SEM model batch sep generated by SEM 40.0. SEM means Aspen Custom Modeler. Aspen Custom Modeler is a different type of modeling method that is available under the umbrella of Aspen Plus. This is not the course for Aspen Custom Modeler, but batch separation process can be used in Aspen Plus domain, and it has been generated by Aspen Custom Modeler tool. Now, even without knowing the Aspen Custom Modeler and its details, we can still use it in Aspen Plus domain, which we are going to do it now. For that, we just bring in this batch separation process module over here. It will look like this, and you will find the details in the block. You have to specify various things like setup, the heat transfer, the initial condition. Because it is a batch process, so we have to set the initial condition for the batch. And then the column internals. The column internals means the internal dimension of the column. That means the number of stages, the height and diameter of the column, etc. And then the efficiency and operating steps. As the batch separation process progresses, how the operating steps needs to be specified, that also we have to learn over here. First, let us go to the setup. Now here, you have to first specify the configuration. The configuration means you have to either specify it as a batch distillation column, or you have to specify it as a pot, just simple pot. Now, if you choose it as batch distillation column, then you will have a pot plus a column like this. And obviously, if you have a batch distillation column, then you have to provide the number of stages of the column. But if you choose it as a pot, then this column will vanish. You will have only the pot. So either you have to use it as a pot or as a batch distillation column. Now, suppose you choose it as a pot, then you have to provide the pot heat transfer as shortcut or rigorous. Now, if you put it as a shortcut, then you have to provide the pot volume in liters or meter cube, whatever. And you either have to provide the phase equilibrium, or you have to provide the model mass transfer in the liquid phase. Model mass transfer means you have to provide the KLA. You know what KLA means? So the KLA you have to provide. If you tick the calculate transport properties over here, then the transport properties will be calculated. And also, so if you assume phase equilibrium, that means the phase equilibrium is achieved inside the pot. So that's exactly what it means. And if you put it as rigorous, then the rigorous calculation will be done in the system, and you do not have to give any information of this nature. And you have to provide the initial condition. So the initial condition, you can provide it as initial charge, or you can say it is empty. Empty means the system begins with an empty pot, and the content that needs to be separated will be provided with time. So that's what the initial condition means. And if you choose the batch distillation column, then there are several options open for you. One is the overhead. So overhead means the condenser. The condenser may be a total condenser. That means the entire amount of the vapor that will go at the top, that will be condensed and come back to the pot. Or else it can be partially condensed. Some of the amount will go out as vapor and remaining will come down to the pot. And there might be an option for partial with second condenser. So whether it is total or partial with second condenser, that you need to provide over here. And if you tick over here, then the reflux drum will be present, and based on whether the reflux drum is present, this particular option will be open for you. So if you tick over here, you should include the reflux drum dump receiver. So this is the distillate receiver. So you have to choose the number of distillate receiver. If you choose 2, that means there are 2 distillate receivers possible. In this case, this is 1 and 2. Now how they will be connected, that will be given over here in the stream. If you have more number of receivers, then logically there should be more number of side streams that needs to be there in the system, which will be drawn and put it into the receiver. Okay, so that's how the number of receivers can be set based on your requirement. Then you have the option for pressure and hold up. You can either specify the pressure or you can calculate it from the tray or packing hydraulics. Now if you want to specify it over here, then this pressure and hold up option will be open for you. So in this case, as it is said, it's specified, then you have to provide the condenser pressure. And if you want to provide the stage 2 pressure, you have to tick over here. Then you can specify the stage 2 pressure as well. Or you can, you may not opt for this. In that case, the second stage pressure is no longer required for you. The system will calculate based on the condenser pressure that you give. So the pressure drop that you specify. So column pressure drop you have to specify, and the condenser pressure you have to specify. The system will calculate rest of the thing of its own. And you have to provide the hold up of the system. So reflux drum liquid hold up you have to specify, and the stages, say starting stage, say if you say that there are 10 stages, then starting stage of 2 and ending stage of say 9, because if there are 10 stages, then the stage number 1 must be the condenser and stage number 10 has to be the pot. Okay, so that is the basic understanding. So number of stages minus 2 will be the number of trays that you can set. Okay, so if you choose number of stages 10, then starting stage and ending stage can be at best 2 to 9, because stage number 1 you cannot use over here. Stage number 1 is always the condenser, and stage number 10 will always be the pot. That's the last stage. Okay, so based on number of stage you choose, your start stage and end stage can be chosen, and the stage hold up in terms of kilomole that can be specified over here. And if you choose calculate it from the tray or packing hydraulics, then all those things will be inactive because they will be calculated based on the condenser pressure and the condenser inlet diameter. So with this column, tray or packing hydraulics, all other calculations such as the pressure drop and the hold up, they will be calculated accordingly. And then the initial condition. When we were discussing about pot, then we had two conditions, initial charge and empty. These are the two initial conditions that we had. But when we have batch distillation, then we have an extra initial condition, that is total reflux. In addition to these two options, we can have total reflux as well. Now go to the stream. Here you have to provide the number of distillate receiver. In order to understand it better, let us go to the main flow sheet and connect the stream. There are one mandatory input, that is the pot charge, and one mandatory output, that is the final column contents. And you have a third stream, that is distillate stream. Okay, so one input, two outputs. So these are the minimum number of inputs and outputs that you have to fix. And other than that, you can see this is an additional feed. Okay, so this is the additional feed. Any number of such feeds you can put in. And there can be multiple distillate streams. So this is S3 is one distillate stream, S6 another distillate stream, and this is another distillate stream. And these are the side product streams. So all those side product streams are taken out from stages. Okay, so from the stages, these side streams can be taken out. And here you have to provide these additional streams. For instance, S4 and S5 are the additional feeds. So you have to provide S4 and S5 as additional feeds. Number of distillate receivers, they are 2. Now let us first convert it into batch distillation column. Then you can see it better. Now this is the pot charge. Okay, S1. Why it is pot charge? Because we have given over here. So this is the pot charge, right? So what is going in B1? So that is the pot charge. So this is only the pot charge. And S4 and S5, these are the additional feeds which can be given on the stages. So here, suppose we have given the number of stage to be, say, 20. Okay. Now we have to say at which stage this additional feed has been given. Suppose we say that it is on the 5th stage and this is on the 10th stage. Okay. So S4 has been given on stage number 5, and S5 can be given on above stage number 10. And this can be mole basis or mass basis. Okay, so that is how the additional feeds can be fixed. And number of distillate receivers, we have said here 2. This distillate receiver 1 and distillate receiver 2, which product stream will come over here? Let us see how many product streams are there. You can see there are S3, S6, S7. There are 3 of them, right? S3, S6 and S7. So S3, S6 and S7. Suppose we say that S3 will go to receiver number 1 and S7 will go to receiver number 2. That is how we fix our S3 and S7. So out of 3 distillate flows, we are receiving S3 and S7. S6 we are not receiving anywhere. Okay, so that's how we fix the distillate receivers. Similarly, the side draw receivers, they are from S8 and S9 because there are 2 side draw receivers. These are S8 and S9. Okay, 2 number of side draws we have chosen. So between S8 and S9, you can fix a name for the side draw receiver and you can say from which stage the receiver will receive the side draw. Okay, because here we have not fixed any stage, right? We have said, okay, S9 is one side draw, but that is coming from stage number of 5 or stage number of 15 or stage number of 19. That we have not fixed. But here we can fix that. We can say that receiver name, we can give it a name, and then stage number of say 17, and it is in liquid phase, basis is mole or mass, and the product stream is 8 or 9, because these are the 2 side streams that we have fixed for the side draw receivers. Okay, so that is how we specify the streams. Then comes the condenser. Based on the type of condenser that we have chosen, whether it is a total condenser or partial with a second condenser, we have to click on them, and based on that, the condenser specifications have to be specified. So either we have to specify the condenser temperature, or we have to specify the distillate vapor fraction. Now, in case it's a total condenser, then the vapor fraction will always be 0. But if it is a partial condenser, then the vapor fraction may be say 0.7 or 0.3 or 0.5 based on how much vapor that is coming out of the system. Or you can specify the coolant, because each and every condenser will be fit with some jacket through which the coolant will flow and it will condense the distillate. Okay, so the coolant temperature or the coolant mass flow rate, all those specifications may be given over here, and accordingly the condenser calculation will be done by the system. Or else you have to specify the subcooling specification, that is degrees of subcooled or subcooled temperature. So based on that, the condenser calculation can be done. If you have a second condenser, then all the information regarding the second condenser also may be given over here. And then the pot you have to specify. Now this is a vessel library available for the pot. You can choose from the vessel library, or you can provide just a few geometric specification, like whether the pot is a vertical pot or is a horizontal pot, whether its head is elliptical type or conical or flat shaped or hemispherical or toruspherical. Okay, so whether the bottom is of that nature or top is of that nature, what is the 10-10 length, that is the cylindrical portion length, diameter or volume. Okay, all those information needs to be given. And then the reflux condition, you need to provide the reflux ratio. Okay, now here also you have to specify the reflux drum geometry, whether it is vertical or horizontal, the head type of that, the tan length, the diameter, okay, and the reflux level. Now, here this is the controller calculation. You have to provide the Kc, that is the gain, Ki, tau d. Set point also you have to provide. Now, this information is required because the reflux level calculation needs to be done. Okay, because one controller is needed for the batch separation process to work. So for that reason, the controller information needs to be given. Now, if it's a reactive distillation, then you have to provide the reaction model. But if your system is not a reactive distillation, then you do not have to give any reaction at all. And if it's a reactive distillation, then you have to provide the information about whether the reaction occurs only in the pot or it occurs in all stages. So based on that, corresponding button will be clicked. Okay. Then comes the heat transfer. Now these are the heat transfer options that need to be given. Now it may be a very shortcut heat transfer calculation, and for that you just have to provide the heat duty or the mass boilerplate or mole boilerplate. Okay. Simplest is the duty. Duty in terms of say kilowatt or megawatt you can give. With that duty, whatever the separation is possible in the system, you want to carry it out. But if you want to do the rigorous heat transfer calculation, in that case, you have to provide the jacket condition, that is the jacket heating. And for that, you have to provide the jacket top height, okay? And for jacket heating, again, you have to provide either heating option, that is the specified medium temperature, or the LMTD or steam heating. So the corresponding information needs to be given, or you can provide the side duty, because suppose there are 20 stages. Obviously, the stage number 1 is the condenser, you take it out, and stage number 20, pot, you take out. So from stage number 2 to stage number 19, each and every stage you can provide the heat duty separately. Okay, if you have that information, you can provide them separately. So that's how the heat transfer is calculated. Then the initial condition. Initial condition means, as I already specified, that for pot type of calculation, you have only empty and initial charge, these two things. But for a batch distillation column option, you have total reflux as well. Suppose if you choose total reflux, then you have to provide either the charge time or the total charge. So total charge means the total amount of material that you give it to the pot. Okay, so that is the total initial charge from where the system starts operating. Or you can give the total charge time, because in general the inlet is given as a flow rate, right? So we always give the inlet as so many moles per hour or so much of kgs per hour. So if you specify the total charge time, say 1 hour, then obviously that means that if your total feed is say 20 kilomoles per hour, and if your total charge time is 1 hour, then it is 20 kilomole. That is the total amount of initial charge that you give in the system. So that is the total amount of charge that you decide upon by specifying the charge time, or you can specify the total amount of charge, okay, either in moles or mass. And you have to provide the initial drum liquid volume fraction. So it may be 0.5, it may be 0.7, anything between 0 to 1. Now, in case you do not want to use total reflux, you can start from empty. That means the system begins with an empty pot. Even for empty condition, you have to provide the initial temperature and pressure of the system. Generally, it is 1 atmosphere pressure. Okay. And last option is initial charge. Here again, if you say initial charge, then the initial temperature and pressure you have to provide. And in addition to that, either the charge time or total charge needs to be specified. So that is how the initial condition needs to be given. And then comes the column internals. So you already know how the column internals are given in the system. So you have to add new, and once you come over here, you have to add the section. Okay, so you have to add the sections. So section number 1, you can say from 2 to 19. Okay, you have to leave the condenser and pot. Other than that, from 2 to 19, you can either choose tray type or pack type. Okay, now if you choose, say, pack type, then you have to provide the packed height per stage, HETP, and diameter. And if you choose packed vendor, then you have to provide the diameter you can view, and here you can choose the packing, either Paul ring or Raschig ring. There are so many options. Okay, and vendor may be either MTL, Norton, Gliese. There are standard vendors available for those packing material. Okay, so all those informations have to be given. So these are the column internals, how you can choose. Now, operating steps, this is important for batch separation process. Now, for instance, you can choose location. So location can be feed, it can be condenser, controller, jacket heating, liquid distillate receivers, reflux splitter, side draw receiver, stage. Okay, now for instance, let us choose feed. And then we have to choose the ID. So which feed? Let us say S1. S1 is the ID, and we choose molar flow rate. Okay, now we give the new value, say 20 kilomole per hour, and ramp time, say we can say 1. That means the feed has been inserted in the pot. Initially it was 0, and at 1 hour time it is 20 kilomole per hour. So the feed has been ramped from 0 to 20 kilomole per hour for a ramp time of 1 hour. So that's exactly what it means. Okay, so that is the operating change. And then the stop criteria. Because it is a batch separation process, right? It is not a continuous process. So any batch process needs to be given some criteria to stop the batch, right? So we can say that the batch has to be stopped after so much of time. So it is a time duration. Okay, or we can say the stop criteria has a process variable, and that process variable needs to be located over, say, condenser, and that variable may be inlet mass fraction, and the fraction should be this. As soon as the mass fraction of that particular material goes below that, then it will stop. And if that doesn't trigger within 24 hours, then also it will stop. Because sometimes it might happen that the fraction will not go below that at all, even if you continue for several days. But that doesn't mean that our process will keep on calculating for something which is not achievable. For such situation, if the process variable trigger doesn't activate within 24 hours, the batch process will stop. That's what it means. Okay. So overall, these are how the specification for batch separation process can be given. Okay. Now we shall solve a problem to understand it better.